moving on in our triangles and angles chapter, looking at different ways to measure angles. I talked briefly about degrees and radians in the last lesson, but this one we're going to go into it in a little more detail. Degrees and radians are different ways of measuring angles, kind of like you can measure distance in either feet or meters. This is kind of the same way. There are ways to convert. So we're going to work on converting the angle measures from one to the other. And we're going to talk about coterminal angles and arc length and sector area, and just a few other things with angles. So there's actually kind of a lot of little bitty things packed into this. Some general angle notes. First, your angles will have an initial side and a terminal side. These are kind of Carboni definitions. The Math League of America may not be too pleased with these definitions, but this makes sense to me. We have something called the initial side. Why is that transparent? That was weird. No, whatever. Okay, that's our, I don't like that. You know what? I'm going to redraw that. There. That's the initial side. And the initial side is typically the positive x-axis. It's going off to the right. Sometimes you'll see it as called the horizontal. And the terminal side is what I call the part of the angle that determines the angle measure. So we have the initial side, which is going to the right, and the terminal side is the one that actually opens up to make the angle. Now you can open up a whole lot. You can actually go all the way around and have like big massive angles of like 300 degrees. But to make this one simple, let's say the terminal side opens up to here, where this one is your terminal. The green one is your initial side. And this, however far you opened up to get to the terminal, is your angle theta. So there's your initial and terminal side. You also have positive angles and negative angles. Going with the same idea, you have the initial side. I'll do it in black this time. There's our initial side. A positive angle means that you are starting with that initial side and opening counterclockwise. So this angle right here would be, just for example, we'll call this an angle of positive. I'm going to turn that blue. We'll call that an angle of positive 60 degrees. Well, you also have negative angles, and all the negative angle means, still starting with the same initial side, but negative means you open up clockwise. So we're going around this way, and this is your negative angles. So this angle right here, I tried to make them about equal. If that's positive 60, I went backwards 60 degrees, so we'll just call that negative 60 degrees. And they are two different angles. One goes counterclockwise, the other goes clockwise. So that is the difference between a positive and a negative angle. It's the direction of travel. Then we have different ways you can measure angles. Degrees are what you're familiar with. If you have a circle, one circle, if I go all the way around in a circle, so here's a circle, I just went around in a circle, boing, see, I told you. If I go in one full circle, so let's say I started right here, and then I go all the way around in a circle, that is an angle of 300 degrees, or I'm sorry, 360 degrees. So I went all the way around the circle, that's 360 degrees. It is also the same thing as 2 pi radians. And the unit for radians, a lot of times, you really don't have to put one, but to kill a dead, we'll just write the word rad after it for radians, and that is accepted by the Math League of America. So 360 degrees in a circle, or you could say 2 pi radians. It's the exact same thing as saying there are 1.54 centimeters in an inch. It's just two different ways of measuring the same thing. And what we're going to do is convert one to the other, just like you could convert feet to miles or feet to meters or something like that. And the conversion is based on the fact that there are 180 degrees in pi radians, which is kind of the same thing as saying 360 degrees in 2 pi radians. All I'm doing is dividing that by 2 to get 180 in pi. So, and the way you convert is the same way you convert other units. To convert a degree, you multiply by pi radians over 180 degrees. And the way that works, so here I'm going to convert 50 degrees. If I multiply by pi radians over 180 degrees, I think of it kind of like you do in chemistry when you multiply different things. You can cancel units on top and bottom. I have a degree on top and bottom. Those cancel, leaving me with 50 pi over 180 radians. And I can pretty quickly divide that by 10. The zeros will cancel. So our answer is 5 pi over 18 radians. Yep. Yep. So you want to cancel units. So if you're trying to convert from degrees to radians, you'll put the 180 degrees on bottom because you want to cancel. If you want to go the other way, if you want to convert radians into degrees, and I forgot to write the rad right there. So we're going to convert radians to degrees. You put the radians on bottom. So here I have 5 pi over 12 radians, and I want to convert that to degrees. Well, now I'm going to put my pi radians on bottom because I need my radians to cancel, and I want to be left with degrees. So my radian on top cancels with my radian on bottom. Also, the pi cancels. Pi cancels pi. And while I'm at it, 12 goes into 180 degrees. 12 goes into 180 degrees 16 times. Sorry, no, 15 times. Yeah. Sorry, brain fart. So 15 degrees. And after all that crazy canceling, 5 times 15 is 75. Everything on bottom canceled. And then that got a little bit messy, but we're left with 75 degrees based on that. So let's do a couple of conversions. The first one is in degrees. I want to convert that to radians. So if I'm going to convert 45 degrees into radians, then I need to multiply by something that cancels degrees. So I want to put my 180 degrees on bottom so I can cancel the degrees. And I know that 180 degrees is equal to pi radians. And when you reduce this, 45 does go into 184 times. So 45 degrees is the same thing as pi over 4 radians. If I'm going to convert this one to degrees, now I have 7 pi over 9 radians, and I want to convert that into degrees, so I need to cancel radians. I'm going to stick my pi radian on bottom, multiply by 180 degrees on top, and now my radians cancel. And let's see what else I can cancel. The pi's cancel. And 9 goes into 180 20 times. And now I can simply multiply. 7 times 20 is 140. And everything else canceled, so I'm left with 140 degrees. So there's how we're going to convert radians into degrees and degrees into radians. Okay, coterminal angles. Coterminal angles, there are two different angle measures, but they still end up in the same place. They have the same initial and terminal sides. You do this by either adding or subtracting 2 pi or 360 degrees. What we're going to do here, and I gave you an example of 90 and 270 degrees. I chose those two angles because they're a little bit easy. Hopefully you know what 90 degrees is. It's a right angle. I meant for that to be black. Blue. There we go. All right, so we have one angle that's 90 degrees. So I'm going to open up positive 90 degrees. Geez. Let's try that again. So I open up positive 90 degrees. And my coterminal, what I'm calling coterminal, is negative 270. And coterminal means that when I go negative 270 degrees, I'm going to end up in the exact same place as positive 90 degrees. And if you think about that, 270, first it's negative, so I'm going to open up clockwise. Well, there's 90 degrees. If I go 90 more, hey, why'd you do that? So I go backwards 90, and then I go 90 more, that's 180. And then if I go 90 more, that's 270. So if I go backwards 270 degrees, you will see that I end up in the exact same place as if I go forward 90 degrees. So those are considered coterminal angles because you end up, in both cases, pointing straight up. You end up with the same terminal side. So to find the coterminal side, and what I kind of breezed over, maybe I shouldn't have breezed over it, you find the coterminal angles by adding or subtracting 360 degrees or 2 pi radians. If you look at 90 degrees, if I subtract 360 degrees from that, you get negative 270. and that was the other coterminal side. So that's what I mean by adding or subtracting 360 or 2 pi, depending on what unit we're using. And here I say find two angles that are coterminal with the given. So what I'm going to do, since I'm in degrees, my first angle for this one, I'm going to do 40 degrees plus 360, which is 400 degrees. And then my second angle is going to be 40 degrees minus 360 degrees, which gives you negative 320 degrees. So those are our two coterminal sides. If you have a huge angle like 400 degrees, all that means is that I started like normal with my normal terminal angle, and positive 400 degrees means we open up 360 degrees and then 40 degrees more. So positive 400 degrees means we just went crazy. We went all the way around once and then a little bit more. That's what a 400 degree angle measure is. And then negative 320 means we go backwards 320 degrees. Pi over 6, we're going to do the exact same thing, except this time we're in radians. I didn't write radians, but if there's not a degree symbol, it's understood radians. So my first coterminal side, I'm going to do pi over 6 plus. We're still going to add 360 degrees, but in radians, that's the same thing as 2 pi. My second one, I'm going to do pi over 6 minus 2 pi. And for the sake of saving you a little bit of time, I'm going to pause this. You do need to get a common denominator to solve this. There we go. So I got my common denominators. I converted 2 over 1 into 12 over 6. That way I can do pi plus 12 pi is 13. The denominator stays the same. Same thing over here. 2 over 1 converted to 12 over 6. 1 minus 12 is negative 11 pi over 6. And so there are the coterminal angles for those two. Then there's just two more things to do. How long have we been here? 12 minutes? Yeah, that's kind of what I was expecting. The last two things, they're not too bad. It's just a formula you're going to have to remember. There's arc length and then sector area. First, we're going to look at arc length. And what I have here, theta is called the central angle. It goes to the center of the circle. And arc length is simply the length. If I could pull out a ruler and measure the length, it is simply this length right there, that length. So your formula for arc length is simply your radius times the angle measure, but make sure your angle measure is in radians. That is vital. Your angle measure must be in radians, otherwise this formula will not work. So formula, it's a clean formula. It's just radius times the central angle, and this is what we're talking about, just that little bitty piece of the circle. So I have a couple of examples. I give you theta and I give you the radius. So if I want the arc length for number 1 here, it is simply your radius times your central angle, which 5 pi over 7 is in radians. If there's no degree symbol, it's understood to be radians. And then I'm going to multiply that. Just multiply straight across. 10 times 5 is 50. Pi over, and 10 is over 1, so it's 1 times 7. And my length would be in inches, because I actually gave you units here. So pay attention. If I give you units, I expect units in the answer. Number 2, we're going to do the same thing. It is going to be r times theta. But here we have a problem, because my theta is in degrees, not in radians. So we actually have to first convert to radians. So first, let's convert this. If you remember our conversions, the conversion, what is this? This has been popping up all day. Go away. I don't like you. It's not even going away. There it goes. Good. Whew, that was scary. Oh, wait, now it's not letting me erase. What's happening to my computer? What'd y'all do? What'd you do to my computer? Jeez. Okay, I have no idea what's happening here, but something happened, and this is frozen in, but nothing else is. See, I can erase my T there, but that can't be erased. I'll tell you what, I can just white it out. There. We'll pretend you never existed. Okay, so I need to convert 30 degrees into radians, so 30 degrees, and if you remember, there are pi radians in 180 degrees. I'm going to put my 180 degrees on the bottom, so I can cancel my units. So my degrees cancel, and 30 goes into 186 times, so my angle ends up being pi over 6 radians. And now that I have my angle, I can use my arc length formula. It's simply r theta. R is 5, and theta is pi over 6, which gives me 5 pi over 6. And in this problem, length is measured in meters. So there is our answer. Just remember, you have to have your angle in radians. And last problem, or last type of problem, not on one page, there's a little bitty triangle man. He's a point triangle man. All right, sector area. We just did the arc length, which is the length from A to B. Sector area is the area of that entire shaded region. It's a little bit hairier, but it's 1/2 r squared theta. And again, theta has to be in radians. We're going to use this formula, 1/2 r squared theta, to find some sector areas. It's just a part of the whole area. So here, 5 pi over 7, my area is pi r squared. I'm going to write it up here. Pi r squared theta. No, 1/2. What in the world? It's 1/2 r squared theta. What am I talking about? I'm getting my regular area circle formula confused here. So I have 1/2 r squared. R is 100. I mean 10 squared times theta, which is 5 pi over 6. And then we clean that up. 10 squared is 100, so that's 1/2 times 10 squared is 100 times 5 pi over 6. And we will clean that up some more. Half of 100 is 50. So 50 times 5 pi over 6. And then finally, 2 goes into each of those. 2 goes into 6 3 times. 2 goes into 50 25 times. And 25 times 5 is 125 pi over 3. And if I'm measuring area and my linear unit is inches, area is going to be in inches squared. So include units if I give you units. Same thing for this one. Again, this is in radians. I mean, this is in degrees, but we have to convert to radians. We just did this angle. This is the exact same angle, so we know that this converts to pi over 6 just for the sake of saving time. So that means my area is going to be 1/2 of r squared, 5 squared, times my angle, which is pi over 6. 5 squared is 25. And nothing cancels on this one, so I'm just going to multiply straight across. I'm going to put the 25 over 1. And let's see, 1 times 25 times pi is 25 pi. Over 2 times 1 times 6 is 12. Nothing reduces there. My unit is meters, so area would be meters squared. And there is everything from this section. I'm actually proud of myself for getting it done in less than 20 minutes. I thought it was going to take a lot longer than that.